Hey class, it's Mr. Zimmerman, and today we're going to continue our adventure with factoring, but we're going to also start to include it. We've been focusing on the skill as an abstract idea. I want you to take something and tell me what two things multiplied to be it. Now you're going to see why we've been training these muscles. So let's go ahead and dive on in. So something I just want to introduce is something you've probably dealt with years. It's called the zero product property. And basically zero, the number zero, product, the answer to multiplication, and property is the rule. So this is the zero answer to multiplication rule. When you are multiplying two numbers, A or B, one of them is zero. Either A is zero and B is zero. So when we're looking at this, when we see two quantities being multiplied, I see right here the pink v plus 4 and the same number minus 3. This is essentially either the pink number or the yellow number. After all operations are done, one of them is 0. So we're going to have a case. How do I make this pink part 0? What number makes v plus 4 equal to 0? Some of you might know it's the inverse, -4. Others may use inverse operations to deduce the sum that when v is -4, the pink part will be 0. So this might be a potential solution. Remember, I'm going to go ahead and test this out. I'm going to plug in for my check. V is -4 plus 4 times -4 minus 3 is equal to 0. Let's examine what happens when I take this input. -4 plus 4 is going to result in 0 times, they're both negative, so I combine them together to form a bigger negative number. And this is absolutely true. 0 times -7 results in a 0. So this is an answer to my question. Now, there are two parts to be aware of. This is going to mean we're going to have two cases to deal with because we have two numbers that can be 0. The pink number, v plus 4, can be 0. What else could be 0 is case 2, when v minus 3 is equal to 0. When is v minus 3 going to be equal to 0? Some of you know from the opposites, it will be positive 3. You can also use inverse operations. Like all answers, I must check the validity of v equals positive 3. Through this check, I can better my understanding. 3 plus 4, 3 minus 3. And then upon solving it, I get 7 times 0 is 0. A similar situation that's above, but notice both are equal. Both make the equation 0. Both satisfy the terms. So I'm going to have to be aware that in these situations, I have two answers. My answer is going to be -4 and positive 3. I need both. So for number 2, you might be saying, hey, I'm going to only have one answer. But when I remember that a square just means the same number multiplied by itself, I see that my zero product property rule is going to come into play. I have two different numbers being multiplied. When are both of them going to be 0? I can see that x is -5, and likewise x plus 5 is equal to 0. I can use inverses if I need to. and I get x is negative 5. Okay, let's go ahead and plug it in. What happens when I plug it in? Negative 5 plus 5 times negative 5 plus 5. And most of you can predict before you're even writing that 0 times 0 is indeed 0. This is true. If I have 0 groups of nothing, I have nothing. All right. What factoring enables you to do is solve problems like number 1 and number 2 that you could not solve with inverse operations. By using the zero product property rule, I can literally cheat. I can figure out equations that would not be solvable. For number 3, I see two numbers being multiplied by each other. 3x and 2x minus 7, a binomial win, which means I'm going to have two cases. 3x equals 0 and 2x minus 7. You might notice I'm kind of switching up. Either do it vertically or horizontally. I'm going to go ahead and solve this. Divide by 3, divide by 3. This is equal to 0. I have to do add and subtract first. I get 2x equals 7, x equals 0. And I get x is equal to 7 halves. So I have my two answers. I do have to check. I really, really do. There's no way around it. To help organize my work, I'm going to go ahead and call this case 1 and case 2. And let's get this started. Let me plug in 0. 3 times 0 times 2 times 0 minus 7 equals 0. Immediately, I'm going to deal with some of these nested parentheses. I end up dealing with 0 times 0 minus 7, 0 times negative 7, and voila. I can see, maybe a step before, that it does work out. Let me go ahead and process case 2, though, algebraically, just for those of you who feel a little less confident with dealing with a fraction. I'm going to go ahead and do the same thing. I'm going to go ahead and plug it in. So I'm going to get 3 times, now notice how I'm writing it, 7 over 2. I'm leaving space over here blank on purpose. Now I have to multiply it by the other group. 2 times 7 over 2 minus 7 is equal to 0. So when you're multiplying fractions, let's go ahead and process this part on the left. You multiply the numerators and the denominators. The denominator of 3 is 1. So it's going to result in 21 over 2 being multiplied by, well, what is 2 times 7? 14 divided by 2 is 7 minus 7. You can see that this is going to work out as well, meaning that my answer is x is 0 and 7 halves. Notice, it does take some space. It will take some space. That's okay. Use your scratch paper appropriately. Show your work for where you need to, and check both solutions. So, for this last one, I'm not going to solve it all, but I do want to pay special attention. It is equal to 0, and some of you might be bothered by this 6. Still, think 6 times 0 times any number is going to be 0. 6 times some whatever number times 0 is still going to be 0. So when you're looking at it, still look at the groups. What makes 5x plus 8 0? And what makes x minus 5 0? And this will set you up on your journey to figure out what the heck is the solution to this equation. That's it for now. This is solving by factoring. This is why we've been working on our factoring so much. This is it. Get good.